at the very top level, we have like a kind of mini tutorial. So this tutorial is you got a user table and an email table that you want to play around with. Okay. So first of all, we need all sorts of extensions, but that's par for the course. And we're going to be using generics.sop, which is sum of products generics. It's just another generics library that Squeal uses for a lot of things, actually. It's kind of like Vinyl. If you've ever used Vinyl, it's useful for heterogeneous lists, and Squeal uses it for that a lot, as well as for generic encoding and decoding of Haskell types. Okay, so the first step is you define the schema of your database, right? So your database consists of a bunch of things. It has tables, it has maybe user-defined types, indexes, user-defined functions. But here's a very, very simple one that only has tables. So the tables are the user table and the emails table. And the users table, so every table has constraints and columns. And so the user columns has an ID column. The ID column has a default and is of type not null PG int4. And the name column has no default and is of type not null PG text. So this triple colon is supposed to connote Haskell's double colon, so it's some value of some type, right? And this colon equals greater is supposed to connote Haskell's fat arrow for constraints. Says that we have some constraint on the data. In this case, columns can be constrained to have either default or no default, and tables can have constraints before their columns. Okay. The constraints for the user table is just that it has a primary key, which is ID. The email column is more, or the email table is a little bit more interesting because it has the foreign key that points to the user table. So the user ID in the email column points to the users table and the ID column in that table. Okay. So I said notice the use of type operators. So we're using type operators, triple colon and colon equals greater for our sort of building up our schema. Oh, and this last one here is I say our database type is public schema. Public is a type family, and what this ends up looking like is just, oh, I don't want this one. So if I do a public schema, the definition of the public type family is that it's just a type level list where we have a public and then your schema is there. Now, in Postgres, you can have multiple schemas. You can have the public schema, which is the usual one, but you can also define schemas that are sort of cordoned off for specific functionality. Okay. So SQL has actually a bunch of sub-languages, right? It has the query language, selects, which is what everyone's most familiar with. It has the data manipulation language, which is for inserting, updating, and deleting data in your tables. And it has the data definition language, which is for actually defining the type of your schema. So there's a little bit of redundancy here because we sort of defined it already at the type level, and now we're defining it sort of again at the value level. But this one is more specific because this one said, for instance, that the ID has a default, but it didn't really say how that default is determined. And here it says ID serial as ID. So we know that the default is just, always increasing. Anytime you add a new ID into the table, it's just the last one plus one, right? And similarly for the ID in the emails table. And also, the foreign key, we want to know what behavior it has on delete and on updates. So this is an example of a data definition. So this is what sets up our database, starting with an empty database, right, which has the public schema by default but is empty, and ending with our database type. And a couple things to notice here is that definitions can use this operator. This is categorical composition, actually. So definitions form a category, and you can compose them using the composition operator. Okay. And another nice feature is that we can always print what our SQL statements are, so that we can look at what the actual SQL that gets run. And that because of the design of Squeal, this is always going to look very similar to the queries you write, right? It should be completely predictable. So Squeal, unlike some other libraries, it's not like a high-level model of how to do queries. Instead, it's very low-level over SQL. It's just an embedding of SQL into Haskell. So if you're familiar with SQL, then Squeal should be not too surprising, at least in its semantics or its syntax, or I don't know what the difference is. Okay. On the other side of creating, you can do teardown, very simple. So you have drop table and you can compose them. And if we print that, it looks like the obvious thing. Okay. Now on the Haskell side, let's say we want to take a user, and that user has a name and an email. So this looks a little bit different from our table, and that's because in Squeal, you don't have to kind of, the Haskell model doesn't have to match your database model, because your database model is maybe more about how you store data and not about the model for your application, right? So maybe you don't want those to be the same. Maybe you want to store things in multiple tables. Like in this example application, we're storing the emails in one table and the users in another table. But here in the model, the username and the email are together in a user type. And we don't even have IDs in this type, because the IDs really kind of belong in the database. Sometimes, maybe there's cases where you want the IDs in your application. Okay, so here's an example of an insert. We can insert one of these users not only into our user table, but also into our email table. And the way we do that is with a with statement. So if you've ever seen with in SQL, that's what this is doing. So we're going to insert into the users table. So first of all, statement has 3 parameters. The first parameter is the database schema that we're type checking it against. The second parameter is the input, the parameters that are being out of line parameters that are being passed to the statement. So that's these parameter 1 and parameter 2. Okay. And the third one is what is being returned. And because this statement isn't returning anything in the end, it returns unit. Okay. So this statement is a manipulation. And inside the manipulation, it's with U as U, E, where U is insert into users, values default as ID, and then we're going to set this parameter 1, which, remember, parameter 1 is going to be the first parameter in this tuple, this record. So it's going to be the username as name. And then on conflict do raise, so it just means if for some reason there's a conflict, which there shouldn't be, but maybe if we accidentally reused an ID, there would be a conflict, and it would then throw an error, throw an exception in IO. And then we're going to return the ID, and along with the parameter that was passed in, uh, as email. Okay, so this makes a common table expression. And now with that common table expression in scope called U, the email insert can say, okay, we're going to insert into emails a subquery where we select, okay, the default is ID, and from the user, from the common user, from the common table expression.
Hey, Eitan,
Yeah,
is it out of scope to ask SQL questions here? Because I think,
no.
you know, okay, what is a common table expression? I get how this is being used, but generally, what does that mean?
A common table expression is like a temporary table that you've created, or really a temporary view that you've created. So this is a little bit of a weird example because it's a manipulation that's creating a view. Usually you think of these as queries that are creating views, but a manipulation can return just like a query can return. So there's no problem with that. So here we have a temporary table, and in that temporary table, we have the ID of the user that we just inserted and the email address of the user that came from the out of line parameter.
And
Okay.
semantically, Sam, this is basically the same as a subquery.
Thank you.
It's an ISO read.
Okay.
So this is kind of a cute example because we can do it all in one statement. The normal way most people would do this in code is they would do this as separate calls. They would do this call, and then in Haskell they would get back the ID, and then they would do this call with that ID, right here, or yep. So this shows you can do it all in SQL, right? All on the SQL side in a single statement. Okay, so this is inserting. Um, if we want to retrieve the users, then it's instead of a manipulation, it's a query. We don't have any parameters this time, but we are returning the user. So notice that it's the opposite. Here it's user to unit, and here it's unit to user. And so you can see that these are inverse to each other in some sense. And so we're selecting. The reason there's an underscore here is because there's a more general select, but this underscore is for when we're just using a list as our selection. We can do more general selections, like you can do select star or select table dot star, but this is just if we have a list of fields that we're selecting. Okay, and from table users as you, because so we're allowed to re-alias these. You don't have to. You could just leave it as users, but this lets us do u exclamation point, which I always think of as dot instead of users dot name. So you can re-alias those. So we have a from, and this from is this thing. So we have our table users as u and inner join table emails as e. Okay. And then this is the on clause. So on u.id equals e.user ID. Okay. So that's very simple. Here's some users. And then here's how we're actually running something. So what we do is we run it in the PQ monad. So PQ db is a monad transformer. So we stack it on top of IO and we just run it. So we execute prepared. Oh, what is execute prepared doing? It's running this insert user statement, but first it's preparing the statement and then running it over all of the users and then deallocating the prepared statement. So that's just a little bit of a optimization that you can do with prepared statements. Okay. And then we can execute our retrieval and get a result. And then you can do multiple things with results, but one of the things is you can just get all the rows. You could also just get the first row or get a specific row. But here we're getting all the rows, and we expect that when we do that. Okay, so here's our session that's running in a monad, but PQ is actually an indexed monad transformer because it tracks what the type of our schemas are, right? And that's changing, right? Because when we do our setup, remember, was changing it from this schema to this schema, right? So this is to invoke the PQ session. So we're going to use this connection string. We're going to, with the connection that connection string gives us, we're going to first run the setup, and then we will run the session, and then we will run the teardown. Okay? And during the session, we're printing the user rows, so we expect that the users we get back are exactly the users that we input in the first place, Alice, Bob, and Carol. So that's the like bare simplest example. And there's a ton more complex stuff that Squeal can do. It's pretty, I won't say comprehensive for Postgres, but it's got a big chunk of Postgres that it covers. And so with that, let's talk about, oh, I forgot to mention one thing, which is that this class I thought was technically under the auspices of the mentorship program, but the mentorship program is supposed to be one-on-one, and there's some more process that is involved, so this is technically not part of that program. And if anybody wants one-on-one mentorship about Squeal, then I'm happy to provide that as well. And then let's go to questions if you guys have questions now, and then we can talk about the example that Sam worked on yesterday that we can try and translate into Squeal as a more beefy example.
I'm curious if you. So I want to use a UUID v4 default. What would be the way of going about that? Is there like an unsafe expression I'd have to write, or
Yeah, you'd have to write an unsafe expression. The reason is that I didn't want to provide in Squeal anything that doesn't come with the base Postgres install, and the UUID v4 is actually coming from an extension of Postgres. So you have to, first of all, make sure that in your migrations you've added that extension, and then in Squeal you would do something like, we'll call it, well, let's look up Postgres, Squall UID generate. That's what it looks like. So this is the function we want, and we'll say UUID generate v4 is going to be an expression. This is a shorthand, this kind of expression. It's actually a rank n type, but basically it means that it will work for any database. So this is an expression of type, any nullity will work at all, right? Because it could be a null PGUUID, or it could be a not null PGUUID. And its unsafe expression okay, let's turn on some.
So you can't show them all the dirty stuff, eh, Tan?
Gotta show
Yeah.
them the dirty
Yeah,
stuff.
you're meant to be the principled one.
Well, I don't know. I actually think that having these escape hatches is one of the design features of Squeal to make it very easy on the one hand to be type safe and also if you know better to write your own stuff. So
No, I agree.
So what do we need here? We need like data kinds, right? Maybe that's what it's complaining about. Oh, I don't even need this. We have type family already. Whatever. Okay. Okay, we'll turn on overloaded strings because this thing is actually a byte string. Okay, so there's our UUID generate v4 function.
I had no idea you could put more than one extension in a pragma.
Yeah, I think most people don't seem to realize that, but I like this style. I don't like doing one pragma per or one. I don't like repeating this thing.
The only benefit of the other one is that you can use like a Vim sort on it.
Mm. Okay. Any other questions? That was a good question. A question in here? Okay. Then how about Sam? Let Sam Jelly know. Why don't we talk about the examples that you were working on and see if we can't translate them into Squeal?
Okay. So I'll paste the link in the chat.
So this is a blog post that was pretty mean about Squeal, but there were some valid criticisms, and I took those to heart in our recent version. But we won't. Let's not get too much into the actual criticism of Squeal, and instead we'll just pursue the project that he's working on. So we're creating a backend for a website with professional hitmen. Think Fiverr or Upwork. I don't know what those are, but okay. But for paid killers, each hitman has a handler. Handlers might handler multiple hitmen, and hitmen pursue marks. Watch out, Mark. Once the job is done, hitmen mark their target as erased. We'll model this like so in our database. Adding an erased marks entity doesn't delete any pursuing marks. Okay, so there's a handlers table. It has an ID, code name, created at, updated at. Okay. So
I ended up not using any of the updated at rows because they are not used in any of the exercise queries, but the created at is important because some of the queries is get the latest kill or something like that.
Okay. So let's go ahead and define these schemas. We'll do a table for each of one, which means that we need a set of columns and a set of constraints for each one. So we'll do type handlers columns. Okay, so this is ID, and it's a default, and it's not null PG int 4 because serials are int 4s. And code name has no defaults. And is a PG text. Okay. Oh, I forgot the created at, which should probably have a default because it should just let's let the database handle that. And this is a timestamp TV. Okay. Oh, and I forgot to say that all of these are not null. Okay.
So I did something similar to that as well. However, since I knew that on the Haskell side, I was probably going to represent time as a UTC time and not as something with timestamps, I used PG timestamp without the TZ, and that didn't work. When I used UTC time, Squeal said it expected a PG timestamp TZ and not a PG timestamp without the TZ. Am I misunderstanding the purpose of either UTC time or the TZ at the end of this time?
Yeah, I think you're misunderstanding the meaning of timestamp TZ, which is associated with UTC time.
Oh, okay.
So we can see what the associations are. If we look for PG UTC time, we see that UTC time is timestamp TZ, whereas local time is timestamp.
Okay. So timestamp TZ does not have a timestamp, does not have a time zone, whereas PG timestamp does?
No. You can get a time zone from a UTC time, I think. I'm not like an expert on the time package.
The time zone is UTC.
Okay. Oh, whereas with local time, it doesn't have a time zone. It just like assumes that it's the
Yeah,
system's local time zone?
it's local to whoever, UTC time is like universal time. So if you have a time and a time zone, then you can get the universal time. But if you have a time without a time zone, then it's relative to whoever put it down, right? If I say 8 o'clock, that means something different to someone in New York and in California. But this is a little bit, the vagaries of time is a little bit off topic. So for now, let's just say you can tell which one is associated, because we see here that UTC time is timestamp TZ and local time is PG timestamp. And this is the same as other Postgres libraries. This isn't like something I innovated for Squeal. I just using PostgreSQL binary, which is the same library that like Haskell, HASQL uses for its association encoding and decoding. Okay, so let's keep moving. We have Hitmen. Hitmen columns. What about the hit ladies?
Would you like me to paste what I wrote? It's
Sure.
just quite time
Yeah.
consuming to type.
Yeah, let's do that. We can also steal it from his library, his code.
Well, no, in the post, they do give the SQL to create it, but not the Squeal types. Do we? Oh, he did
Yeah.
write everything in Squeal as well.
Yeah, he
okay,
did.
so we can steal it.
Unless you posted it already, did you?
I did post it as a comment in the right-hand bar. Maybe just scroll down.
Oh, there it is. Okay.
Looks like it got cut off. I'll paste it again as separate comments.
Okay. I'm going to include the updated at just because it does. Okay.
Is it irritating?
I'm actually going to put my schema at the top here. And my database is going to be just the public schema. Okay. All right, so there is a little bit of redundancy here. We have this created at and updated at in all of our tables. So is there a way we can reduce through redundancy so that we don't have the same two things in every table? Sure, I could do, let's say our, what do you call them? Meta columns. Okay. And if I wanted to, I could then, well, first of all, before we do that, let's see that this compiles. Oh no, we need to turn on extensions. Okay. And we'll probably need more before the day is over. Okay. So we could do this and get rid of these things. And instead do them here. If you think that that's cleaner. It's just a question of choice. So join is type level appending of two lists. And so these mean the same thing. Join is just a type family.
Is there a nice way to like do a map and like map that in?
No, because saturated type families make map impossible to define.
Darn.
You could define your own.
There are some complex workarounds which are
And,
out of scope for this
columns,
class.
Columns equals
Yeah,
join,
yeah.
meta columns, and then you could do it that way. Oh yeah, we want. Anyway, so this means the same thing, but it's maybe a little less redundant or more redundant, depending on how you think of it. Okay, so here's our schema, but that's just our schema. What about actually creating our schema? So we will make a setup function, which is a definition that's going to go from the empty public schema to our schema. It's an undefined definition. That's kind of funny. Okay, so what is setup got to do? Well, we got to create all these tables and we got to create them in the order that it says. everything is in the public schema, so we don't need to qualify it. But if we were doing this in another schema, if we were doing it in, Hitman, because that's where our application is and we want to live next to other applications in the same database, then we would need to say Hitman dot whatever, or Hitman exclamation point, whatever. So, but this one is fairly simple still. So we're going to create table. And the first table we're creating is handlers. And let's ask, what is the type of create table? Oops, it's not a function. Okay, so it has, as its first argument, a qualified alias. That's what this is. It's an alias. If I wanted to qualify it, it would be public.handlers. But since I don't need to qualify anything that's already in the public namespace, I don't need to bother. Okay. The next thing is going to be a list of column type expressions, followed by a list of table constraint expressions. NP is like a list. It's a heterogeneous list. It stands for n-ary product. Okay. So for now, I'll do this. And this last one doesn't need it. Okay. So this is what our setup is going to look like. And let's see that it complains about stuff. Uh-oh, variable not in scope, hashtag. That's because we're using magic overloaded labels extension. Any questions about the overloaded labels extension? Okay, so the first hole here, it wants a list of column type expressions, and it even tells us that that list needs to give us identity, default, not null, PG, and 4. So it's not too hard to figure out what that is. It's going to be serial as ID. And then we'll say not nullable text as code name. And we'll say not nullable timestamp TZ as created at and then we want more than just that. We also want it to have a default of now. Right? Whenever you do an insert, it should, if you don't provide a created at, it should just use the now time. Okay. So that's the columns. Hopefully that's right. And then the constraints is that we have a primary key. And our primary key is the ID. And we have to name our primary key. So this is, in Squeal, you're forced to explicitly name your constraints, whereas in normal SQL, you can just have it sort of generate those names for you. But it's a good practice anyway to specify the names yourselves, I think. Okay, so what are they named here? They're named PK handlers. Okay. All right. So similarly, we're going to do these guys, and what's in here? For Hitman, we have ID, codename, and handler ID. It's very similar to handlers. The only difference is that we have a handler ID. So we can go ahead and copy and paste this. We're just missing a handler ID.
In the interest of
Handler ID.
time, maybe we can stop after the Hitman table because the first query only involves those first two tables.
Okay, sure. We can do that. And this needs to be an int4, or you can even say int. And it's pointing to, okay, so now we say we have a primary key. And we also have a foreign key, which is the handler ID. And it refers to the handlers table, the ID column, and then on update cascade, and on delete cascade. And this is as probably FK Hitman. Okay. And let's leave these out for now. Okay, what didn't it like? Oh. All right, so why is it complaining? Couldn't match type with has updated at with empty arising from as. Probably because we're missing. So this is an example where the type errors doesn't really give you that much help, but we're clearly missing a little comma here. This operator is what we use to create these heterogeneous lists. And there's a missing nil here that we get through a technique called scrap your nils, so we don't need to write it. Oh, here's an actual, look, I misspelled something and it caught me. Yeah, hitmen, not hitment. Oh, and here's another one. Okay, so now we have our setup. We have our schema, and we've set it up, and we can define our teardown easily enough. And our teardown is just going to drop table hitmen, followed by drop table, what was it called? Handlers. Okay. Oh, now. Again. Okay. So now let's actually define some queries and manipulations. So what did you have in mind for that, Sam?
The first query is very simple. It's just list all the hitmen.
Okay. List all the hitmen. So we want to select hitmen. Why do I keep adding a T? I think it's my keyboard. Okay, so I want this to be a statement. And it's going to, it doesn't have any parameters, and it's going to give us back a hitman. It's really going to give us back the list of all hitman, but a single row is a hitman. So we're going to say data hitman. And for
One
now,
question I had is about anonymous rows. Do you have to define a new data type, or can you have an anonymous row? Like, yeah.
Good question. For now, we'll do it with a data type, and then we'll do it with an anonymous row. I'll show you how to do that in a minute. That's a good question, but let's get to that. Remind me in a minute, okay? So for now, we're just going to say hitman is exactly the same as our table here. Sort of, but in Haskell, right? So this should be ID is of type int32. Code name is of type text. And handler ID is of type int32. Okay. And we'll say select hitman equals select star from table hitman. Okay, so int32 needs to be in scope. So does text. Okay, couldn't match statement. Oops, I need to say that this is in fact a query. Okay, now it's saying it's complaining couldn't match generics.sop.record.toRecord code data type hitman with an actual thing. So it's trying to apply some crazy type family from generics, from SOP generics to hitman, and it's just not able to. And the reason is we need to derive some classes. So we're going to derive stock ghc.generic, and we're going to derive any class sop.generic, and then another one sop.has data type info. Okay. So the sop.generic tells me how this thing can be encoded as a sum of products, and really it's just a product, so there's no sums involved. And the has data type info tells me about things like the field names. Okay. And I better import ghc.generics as ghc and generics.sop as sop. Okay, so let's see what it complains about now. And we need to turn on deriving strategies. Okay, and we need to turn on derive generic. Okay, and we need to turn on derive any class. Okay, so what is it complaining about now? It's complaining that we don't have our metadata. So that should say updated at and created at. And I intentionally did something wrong here, and we'll see it complain. And we need to import, what is it? Data.uuid.types. Oh, not UUID, UTC time. That's data.time. Okay. So it couldn't match type created at with updated, and that's because the order here is not the same as the order in our table, because in our table the created at is before the updated at. And this is something that Squeal enforces, that your record order matches the table order if you're doing something like select star. So let's make sure it's in the same order as the table. Okay. So now we have a select statement. Cool. What's next? Oh, next was Sam, or who had the question about can we do an anonymous record?
That was me.
Who was me?
Sam Schlesinger.
Sam. Okay, that's what I thought. Okay, so sure, we can. So let's. What is an anonymous record? It's just a tuple. So let's do that. We'll do like that. Int 32, UTC time, UTC time. So what we're going to need to do now is this function here, query, is a smart constructor for a statement. And what it does is it says, okay, if your input is a generic tuple and your output is a generic record, then just use generics to generate the encoding of your parameters and the decoding of your results. But for an anonymous tuple, I can't use generic decoding because it doesn't have the same fields as the table. So I'll have to do this explicitly. So for that, I use the capital Q query dumb constructor, right? And this has some params and row, and let's ask GHC what their type is. Maybe it's smart enough to figure that out. No, it's not smart enough. Ambiguous type variable. Okay, but we know what these should be. Params is, since this is empty, I can use a function nil params. And for this one, I'm going to do row is, so this is my row, this is my decoder. So this set, so I have a table whose columns are the columns of Hitman. And I want to say from each column, I want to populate this tuple, right? So I can even just do something like this. 1, 2, 3, 4. And we can leave out the do and do this applicative style. And we can do this. ID, code name, handler ID, created at, updated at. And this is super useful because on Haskell's side, we don't usually name things exactly the way you would in the Postgres side, right? You do these crazy prefixes and stuff. So sometimes you want to do this sort of explicit decoding. Okay. Oh, we don't want to call it row. Sometimes I call these enc and dec, or encoder and decoder. Okay, so that's how you do it anonymously. Okay.
Thanks.
No problem. Next question. Sam Gelino. I assume we want to do select Hitman by ID, right?
Well, I haven't done the other queries yet, but already on this first query,
Okay.
you said, oh, for now, let's use the exact same definition as in the table. Whereas I didn't want the ID on the Haskell side.
Okay.
And also, I would like to use like a key handler instead of int32 for the handler ID. And I figured out how to do how to drop the identity, but I have not figured out how to do the key handler.
Okay. So let's do new type key A equals key int32, I guess. Is that okay, or do you want something else for this key?
No, it's fine.
Okay, and then we'll have that this is a key handler, and we also have some data handler, which we don't care about for now, right? And
well, we already have a handler data type. Oh no, we defined the table handler, but not the data
right.
type handler. Okay.
We didn't define a Haskell data type for handler yet. Or now I have, but it's empty. Okay, and you said what about created at and updated at?
I didn't say anything about created at and updated at.
You want to just leave them in?
Sure.
Okay. And do you want these to be named in this fashion, or is there a particular naming that you prefer?
I would prefer the camel case version.
What about codename? No, that's fine. Okay. All right, so let's get this hitman out of here. Now, instead of selecting star, I want to select some specific fields because I don't want to select the ID field at all. That's one way to do it. Another way to do it would just be to ignore it in the decoder, right? Just forget about one of the fields, right? But that's maybe slightly inefficient. I don't know. So we'll do select, instead of star, we'll do a list. And let's put hitman back here. And our list is going to contain it's going to contain the code name. It's going to contain the handler ID, but we're going to rename it as handler ID. And it's going to contain the created at, renamed as created at, and it's going to contain updated at, renamed as updated at. Okay, and we don't need this stuff anymore because now we're just doing the generic thing, right? Because now the field names do match exactly the field names here. But it's going to complain, couldn't match PG of key handler with PG int4. Okay. So what we're going to do is we're going to say this key is basically from the point of view of Postgres, the same thing as PG int4. And we're going to say that by doing deriving new type, because we're going to use new type deriving. What are we going to derive? We're going to derive is PG. Okay. And we're going to derive, well, let's do that for now. We'll derive new type is PG. Okay. Okay, so we have to turn on generalized new type deriving. Okay. So now it's changed it from saying it doesn't know what PG of key handler is to not knowing what from PG of key handler is. So let's ask GHC, what is PG of our key? PG of a key handler. Oh. Why is key not in scope? Why is handler not in scope? Some GHC people tell me what to do to make them in scope.
code? I don't know why it's not in scope.
Oh, it's because it didn't. It's because it didn't. All right, so let's fix this type error, and then it'll be in scope, and then I'll ask. Okay, so it says we don't have from PG, so we'll derive that as well. Okay, so now if I ask what is the kind of PG key handler, it tells me PG of key handler is of kind PG type and is equal to PG int4. Okay. So that's how you would do that, Sam.
Okay.
And there's a lot of options here. Like for instance, there's this simplification. You can use select, and then you don't need to bother saying list. Right, and we didn't even need to really bother with this renaming. We could have done it in our decoder instead. If we wanted to. Mm-mm.
You need $1 on line 134?
Ah. Okay. Okay. Now, the next thing that we want to do is not just select all hitmen. In fact, let's call this all. We want to do select a hitman, right? Where we give it a key hitman, right?
Should we do that next week since we're out of time?
Oh, are we out of time? Sure. We can do that next week. Any last questions before we go?
Is the order of fields an intentional choice or more of non-intentional for some other reason?
It's kind of a choice that was forced on me. If I could do it easily without enforcing an order, that might have been better. But yeah.
Okay, great. Thanks. Enjoyed a lot.
Okay.
Thanks.
Thank
Thank you.
Yeah. Do you guys want to repeat this next week?
Yep.
Okay, I will set that up.
By the way, I'm loving Squeal. Like I would say like 80 to 90% of my bugs in code come from DB stuff, and I've had 0 bugs ever since I've started using it. It's definitely like you definitely pay. At least I'm definitely paying on the front side. Like it's harder for me to use than SQL, but I'm using it more correctly. So.
Yeah, okay, cool. All right, bye guys.
Bye.
Ciao.
How do I get this recording?
Right.